Yes, hello, Mr. Bhatt Bakhtiar. Welcome on YourPedia platform, and let's start your heat transfer snap for your JKPSC interview for the post of Assistant Engineer in Public Works Department. But today you prepared heat transfer.
Yes, sir.
Today you prepared heat transfer subject.
Sir, yes, sir. Heat transfer.
So what is heat transfer? Let's start with this very simple question.
Sir, heat transfer is a subject that studies different modes of heat transfer for the development of relations for calculating the rate of heat, rate of cooling. Sir, heat transfer is mostly just concerned with calculating the rate of heat, rate of cooling, rate of heating.
Acha, you know, on if you observe some kind of electric motor.
Electric motor, yes, sir.
Yes, some fins
yes,
you will find at the surface of the electric motor. Some fins you will find on the surface of electric motor.
Sir, it's not audible, sir.
But I think there is some issue at your end. Please check.
Yes, sir.
Okay. You know, if you will consider electric motor.
Yes, sir.
You will find some fins at the surface of the electric motor.
Yes, sir.
So if you will consider that electric motor as a cylinder, okay.
Yes, sir.
A horizontal cylinder, then what kind of fins you can provide? Like suppose you are, I'm giving you a chance to design that motor. So you are having, you know, you can choose a different kind of fins which you can provide on the surface of that horizontal cylindrical motor.
Yes, sir. Sir, we can provide two types of fins. Sir, one is the annular fin, and second is the straight fin. The straight fin will run parallel to the length of the cylinder, and the annular fin will be on the circumference of the cylinder in circular fashion.
Okay, so which kind of arrangements will give us better results, and why?
Sir, I think that it will be just the one that one is parallel.
But today there is some issue at your end. I think internet is not that much good. Your voice is breaking in between. But can you tell me the significance of Grashof number?
Grashof number?
Yes, physical significance of Grashof number.
Sir, Grashof number governs this natural convection, determines the type of flow in natural convection.
Type of flow means what? Like the laminar or turbulent flow in natural convection?
Yes, sir. Yes. Yes.
Are you sure Grashof number tells us about the nature of the fluid flow? Or it is Rayleigh number which tells?
Sir, it is also Rayleigh number, but it is also sometimes considered Grashof.
Then how?
Less than 10⁹ it is laminar, and
that is Rayleigh number.
Rayleigh number.
Or Grashof number.
Rayleigh number.
Rayleigh number. So that's why I'm asking you, what is the significance of Grashof number?
Sir, Grashof number, it is basically the ratio of viscous force divided by the inertial force.
What do you understand by a black body? But
sir, basically what happens is that, sir, every body emits some energy. Sir, black body is that body that emits maximum radiation at a given temperature compared to other bodies. It has the tendency to absorb all the radiations that are incident on it, and also has got the tendency to emit all those radiations. And it's also a diffuse emitter. It emits radiations equally in all the directions.
But what is the difference between the drop-wise condensation and film-wise condensation?
In drop-wise condensation, film is not formed. While as in film-wise condensation, a thick film is formed between the condensing fluid and the surface over which it is condensing.
So in which case heat transfer will be more, drop-wise or film-wise?
The drop-wise.
Drop-wise condensation. So how you can achieve that drop-wise condensation?
Sir, so this application of oils, applying oils on the colder surfaces.
But what is LMTD?
Sir, LMTD stands for logarithmic mean temperature difference. Sir, in these heat exchangers, there is not a constant temperature difference between the hot fluid and the cold fluid. So we use this LMTD.
Can you tell me something about the overall heat transfer coefficient? What is overall heat transfer coefficient?
Sir, overall heat transfer
coefficient.
Sir, for example, sir, we have a cylinder over which there are multiple levers. For example, composite cylinder. The heat transfer coefficient on inside and outside, they will be different. For this case, we use overall heat transfer coefficient that gives the combined effect.
But what is critical radius of insulation?
Sir, critical radius of insulation is that radius of insulation at which resistance to heat transfer is minimum. Heat transfer is maximum.
So how you can define it for a sphere? What is critical radius of insulation for a sphere?
Sir, for a sphere, it is equal to 2K by H. Sir, K is the thermal conductivity of the insulating material and H the outside heat transfer coefficient.
Achha, how you got that relationship? Can you tell me some basic about that? Like from where you get this relationship?
Sir, yes, simple, sir. I defined this as the that radius of insulation at which heat transfer this resistance is minimum. Sir, we will take the resistances. Sir, one will be the resistance offered by this insulation, sir, conductive resistance, and the second will be the convection resistance. Sir, by this differentiating it, we will get the relation.
What is a black body? What?
Sir, I told you black body, sir.
Repeat once again.
Sir, black body is any idealized surface that emits maximum rate of radiation at a given temperature. Sir, it is the body that absorbs all the radiations that are incident on it.
So how you can develop a black surface? Like suppose we want to have a surface which is having a very high emissivity. So how you can achieve a black body kind of surface? Can we achieve it practically?
Sir, I told you that it is an idealized surface, but we can, for example, sir, we can appear it to be, we can make it to appear like this black body. So, for example, by coating black color.
A body which is looking black is a black body.
No, sir, it also happens. Black body has also got some this black body characteristics. By increasing the absorptivity of surface.
I just suppose we are having, some kind of paint, okay, black paint. Sir. To which one will give us more emissivity? A rough black paint or a shiny black paint, and why?
Sir, shiny.
Shiny black paint will give us more emissivity.
Yes, sir.
Why?
Sir, surface roughness will be there on the rough. That will offer some resistance, sir, to the radiation heat transfer.
Are you sure shiny black will give us more emissivity?
Yes, sir.
Achha, don't you think like shiny black will having more reflectivity? Shiny black will have more reflectivity?
Sir, it depends on which type of material is.
The shiny surface, the plane surface, a very smooth plane surface will have more reflectivity. Rough surface having more absorptivity. Shiny surface will have more reflectivity, less absorptivity. Nahin? Suppose you are having an aluminum plate. You are having a rough aluminum plate or a
aluminum has got a high reflectivity.
No, just consider the surface characteristic. But take any surface, aluminum, copper, any material. Take any material surface. The rough surface will have more absorptivity and the shiny surface will have less absorptivity. Nahin?
Yes, sir.
So if by providing the shiny black paint, absorptivity is decreasing, then how the emissivity can increase?
I don't think so.
Okay, but suppose you are having a vertical plate.
Yes,
okay,
sir.
a hot vertical plate at some temperatures, say 100 degrees Celsius, a square plate of some particular dimension.
Yes, sir.
And we know the dimension. Tell me the basic process, how you can find out the convection heat transfer coefficient. Suppose this is a vertical plate standing in a room. The area of the plate is known to us. The surface temperature is known to us.
Yes, sir. Sir, there is a condition that's called a no slip condition. Sir, no slip condition states that the layer of the fluid that is in contact with the surface has got the velocity of the surface. Sir, surface is at rest. The layer of fluid that is in contact with the surface, sir, it will be also at rest. Hence the this heat transfer convection will be equal to the conduction. Sir, convection is HA delta T. Conduction is KA dt by dx.
But unmute yourself. Unmute करो आप. Mute हो गए हो. Go ahead.
Sir, we can easily find out this. H is equal to K dt by dx upon delta T. Hello, sir.
अच्छा, but एक बात बताओ मेरे को, suppose if you will take a transformer or a motor or any component.
Yes, sir.
By attaching some fin, our aim is to
increase the heat transfer.
Increase the heat transfer. But
yes,
don't
sir.
you think, like, if the heat transfer is increasing, the performance of that device is going to decrease because more is the energy loss to the surrounding?
Sir, motor में कहाँ होगा this efficiency decrease?
आपसे पूछ रहा हूँ मैं, but because more is the heat transfer, because that heat transfer is nothing but the heat lost.
Sir, yes, but we have to also maintain the temperature. We don't have to allow it to go beyond some limit. सर टेम्परेचर भी तो ज्यादा नहीं होना चाहिए ना सर. अगर टेम्परेचर ज्यादा हो गया तो मटेरियल हमारा ये ब्रेक हो गया, फॉर एग्जांपल फ्रैक्चर हो गया.
अच्छा चलो, लेट्स टेक एन एग्जांपल ऑफ आईसी इंजन.
यस सर.
आईसी इंजन में आपने बहुत ज्यादा हीट ट्रांसफर कर दिया, तो इवन द टेम्परेचर कैन ड्रॉप टू ए वेरी लोअर वैल्यू, इंजन टेम्परेचर.
सर आईसी इंजन में हम यूज करते जिस स्कूटर में हम यूज करते फिनल.
हाँ, तो वहां पे क्या करेंगे? हीट ट्रांसफर, मैक्सिमम हीट ट्रांसफर करेंगे, ऑप्टिमम हीट ट्रांसफर करेंगे, क्या करेंगे?
सर उतना जितना हमें मेंटेन करना है सिलेंडर का टेम्परेचर, तो उतना तो हमने करना है, उससे ज्यादा तो नहीं देने जाना है.
तो वहां मैक्सिमम नहीं करेंगे हम हीट ट्रांसफर.
यस सर.
वहां पे मैक्सिमम हीट ट्रांसफर नहीं करेंगे, वहां पे ऑप्टिमम करेंगे या कुछ और करेंगे?
सर ऑप्टिमम ही करेंगे, मैक्सिमम थोड़ी सर, वो तो ज्यादा लॉस होगा ना सर. फिर
वहां पे लॉस हो जाएगा, वहां पे लॉस नहीं हो रहा है.
कहाँ पे सर?
इंजन के केस में यू आर सेइंग दैट इज अ लॉस.
यस सर, इट इज अ लॉस. इट इज लॉस टू द कूलिंग मीडियम.
ओके, बट माय लास्ट क्वेश्चन टू यू.
यस सर.
आप मेरे को बताओ कि ये क्रिचॉफ्स लॉ क्या होता है? व्हाट इज क्रिचॉफ्स लॉ ऑफ थर्मल रेडिएशन, एंड कैन यू प्रूव दैट रिलेशनशिप?
सर फॉर एग्जांपल सर, आई विल एक्सप्लेन इट थ्रू दिस वे. सर हमारे घर में फ्लास्क होती है. फ्लास्क क्या करती है सर, ना तो बाहर हीट फेंकती है, ना तो अलो करती है अंदर की तरफ हीट. isn't it sir? Hello sir.
Yes, but I'm listening to you.
Sir, Kirchhoff's law simply state करता है कि a good absorber is a good emitter, and reverse is also true. Bad absorber is a bad emitter. Absorptivity of सर ये बताता है कि ब्लैक बॉडी की जो absorptivity है वो इमिसिविटी के बराबर है.
चलो ठीक है, बट मैं आपको फीडबैक देता हूँ अभी।
यस सर।
देखो बट जब आप आंसर करते हो ना, ज्यादा हिला डुला नहीं है, सीधे कंफर्टेबल सीधे बैठ के आंसर करने हैं।
यस सर, यस सर।
ये बॉडी मूवमेंट बहुत ज्यादा नहीं होना चाहिए।
ओके सर, वो पता
मोस्ट
है।
ऑफ द क्वेश्चन यू आंसर्ड। एक दो चीजें जहां पे आप थोड़ा स्टक हो गए थे। देखो ब्लैक बॉडी आपने डिफाइन किया, ठीक है, ब्लैक बॉडी डजंट मीन कि कलर ब्लैक होना चाहिए।
सर यस
लाइक
सर।
स्नो, अगर हम स्नो का केस
सुनो,
लें तो स्नो इज ऑल्सो
इंफ्रा,
ब्लैक बॉडी, कलर तो उसका
यस
व्हाइट
सर,
होता है।
फॉर
अगर आपने
इंफ्रारेड लाइट।
ब्लैक पेंट करना है ना, तो रफ ब्लैक पेंट करेंगे। रफ सर्फेसेस आर हैविंग मोर एब्जॉर्टिविटी, सो दैट दे आर हैविंग मोर एमिसिविटी आल्सो। रफ सर्फेसेस का जो एमिसिविटी है वो ज्यादा होता है एज कम्पेयर टू शाइनी सर्फेस।
एब्जॉर्बिविटी सर।
तो अगर पेंट करना है तो कौन सा पेंट करेंगे? रफ ब्लैक पेंट करेंगे, या देयर आर सम सिलेक्टिव कोटिंग आल्सो यू विल फाइंड इन द मार्केट। सिलेक्टिव कोटिंग से भी हम करके हम क्या कर सकते हैं, वी कैन एनहांस द एमिसिविटी और एब्जॉर्टिविटी ऑफ द सर्फेस। So what you need to say, sir, according to Kirchhoff's law of thermodynamics, a surface which is having high absorptivity, it will have more emissivity also. For body in thermal equilibrium, absorptivity equal to emissivity. तो अब हम आपको सोचना है कि how we can increase the absorptivity of a surface. अगर आपने surface की absorptivity बढ़ा दी तो its emissivity is also going to increase. Black body is a perfect emitter and perfect absorber of heat. तो वो थोड़ा आपने गड़बड़ कर दिया था। ओवरऑल हीट ट्रांसफर कोएफिशिएंट जो U होता है, तो बहुत कॉमन है, आपने डिफाइन नहीं किया इसको, कहाँ अटक गए थे आप इसमें? कैसे डिफाइन करते हैं? जो U होता है ना, 1 by UA, द प्रोडक्ट ऑफ U इनटू एरिया, द रेसिप्रोकल ऑफ 1 by UA, 1 by UA, सॉरी, 1 by UA इक्वल टू व्हाट? द समेशन ऑफ ऑल द रेजिस्टेंसेस। तो U क्या है? ओवरऑल हीट ट्रांसफर कोएफिशिएंट इज अ पैरामीटर व्हिच वी आर इंट्रोड्यूसिंग to consider all thermal resistances into a single quantity. So 1 by UA represents summation of
all the resistance,
all thermal resistances. कंडक्शन कन्वेक्शन हो, तो इसको थोड़ा सा देखना था आपको। जितना ज्यादा U होता है, more is the heat transfer. More is U, lesser are the resistances. Okay, and more is the heat transfer. तो बाकी चीजें तो आप आंसर कर रहे थे। खैर, मैंने सब मोर क्वेश्चन आई आस्क्ड यू लाइक क्रिटिकल रेडियस, फिल्म मोड ड्रॉप वाइज कंडेंसेशन, वो ठीक है, वो ठीक बताया आपने। ग्राशोफ नंबर का सिग्निफिकेंस में आपने गड़बड़ कर दिया था, बट ग्राशोफ नंबर क्या बताता है? ग्राशोफ नंबर हमें बताता है कि कितना जो है नेचुरल कन्वेक्शन है। ग्राशोफ नंबर हमें क्या बताता है? ये बायोन्सी फोर्सेस के बारे में बताता है, कि कितना फास्टर ए फ्लूइड इज मूविंग, कितना नेचुरल कन्वेक्शन जो है वो डोमिनेट करेगा। तो डोमिनेंसी बताता है अपने को नेचुरल कन्वेक्शन की। प्रोडक्ट ऑफ ग्राशोफ एंड पेंडेंट, दैट इज रेले नंबर एंड दैट टेल्स अस अबाउट द नेचर ऑफ फ्लूइड फ्लो। तो खाली ग्राशोफ अपने को नहीं बताता नेचर ऑफ फ्लूइड फ्लो, इट्स प्रोडक्ट ऑफ ग्राशोफ एंड पेंडेंट व्हिच टेल्स अस द नेचर ऑफ फ्लूइड फ्लो।
यस सर, यस सर।
थोड़ा जितने भी डायमेंशनलेस नंबर है हीट ट्रांसफर में, सबका सिग्निफिकेंस रिलेशनशिप देख के रखना है, बट ठीक है। और थोड़ा जब आंसर करते हो तो स्टेबल बैठना है, सीधे बैठना है, ज्यादा हिलना डुलना नहीं है। बाकी ठीक है, आपका टेक्निकल अंडरस्टैंडिंग अच्छा है, तो ठीक है, आपका डिलीवरी स्टाइल तो ठीक है, मेहनत करते रहो, शॉर्टली यू विल गेट थ्रू दिस।
ओके सर।
ओके।